Welcome to SolidWorks Live Design. SolidWorks Live Design is a series we run here at SolidWorks that is dedicated to pursue of learning one another using a medium of live demo and exploration as we share your favorite software tips and tricks. And this session, as you can see, is dedicated to deep dive topics, specifically topics that are near and dear to our guests and presenters' heart. And that they will be diving deep, really deep into for no reason other than they immersely interested to exploring the topic deeply and sharing the exploration with all of you. My name is Gurpreet Singh, and today we are joined by someone who is biomedical engineer and a teacher at heart and proficient in SolidWorks. Aryan Farhani. Aryan, you are prepared to deep dive into the topic today. Can you tell us something about yourself?
Hi, thank you very much. I'm Aryan, and I'm very glad to be here. I was thinking about what would it take to start designing something from scratch, and I thought it would be a good idea to share it with everyone. That's why I'm here.
Wonderful. So I think let's get right into the show, and we are probably showing your screen, and let's deep dive in it.
Sure, sure. I wanted to talk to the viewers and tell them you are watching this video right now on a monitor somewhere, maybe a PC, maybe a laptop. That monitor is sitting on a desk, and it's just enough to look around for 2 seconds and you see unlimited or maybe finite number of physical products wherever you are. And there was a time each of these products didn't exist before. At some point someone brought them into this world. So unlike my typical videos where I go inside the interface of SOLIDWORKS and go in tips and tricks of what to click, when to click it, and how to click it, I was thinking, why wouldn't we want to talk about bringing something to this world from scratch for the first time, from thin air, something that is inside your head right now, or maybe not yet, but at some point. And this is what I want to focus on in this session. So, for example, right now on the screen, you see a photo of my bedroom, which is in the other room. And that portal looking thingy is a wall lamp that I designed and 3D printed and mounted on my own wall. It didn't exist before. I mean, we do have lamps looking like this before, and I wanted to buy one. Then I realized only the ones with about 80 centimeters in diameter are reaching over $300, $400. And I couldn't convince myself to buy one, especially after I checked other sources and I saw that people are doing drop shipping. These are actually 20 bucks, and you can buy them on Amazon for 400. And if I wanted to buy that 20 bucks, because I'm buying only one unit for myself, I have to pay even more than 400 for the delivery. So I couldn't convince myself to buy one. So I thought, why don't I make one for myself? Now, how do I do this? All I know is it has to be a ring, it has to have a light, a soft light hidden behind it, and somehow it needs to be mounted on the wall without us seeing any disconnection in the ring light that actually appears on the wall, and the other factors eventually come to play. I cannot think about them right now. All I know is I want something like this. So this was the idea. I don't want to focus on this. I want to focus on something a lot smaller. And that's why we are going here.
Yeah, Ayan, before we jump into it, I really like your idea of creating something new from inception, from your mind, because I think most of the attendees today have a similar thought process, and in their lifetime, whatever they think in their mind, they probably use our SolidWorks to get it physically created, and Personally, I was really touched with your approach. And to be honest, the moment you have shown the slide, it reminds me of the Spider-Man from the different universe. You remember a movie?
Yeah, the portal. Yeah.
Yeah, the portal to the other universe or other dimension. So
Yeah.
it's pretty interesting. Yeah,
Thank you. Thank you. Yes, yeah, and you are absolutely right. That's why I chose this topic, because the majority of the audience here are able to imagine things in 3D. That's why
yeah,
they work with
yeah,
SolidWorks. That's why they're here. And I'm not sure, but I think a good portion of them, if they are not already, um, are mechanical engineers, are becoming one, but they don't
yeah,
have to necessarily be one. But whatever they are, wherever they are able to create solutions and have an understanding of 3D.
yeah.
Some people are good at making music, I'm not, and we are good at 3D. So that's why I wanted to bring this topic up.
Yeah, but I remember when I have learned SolidWorks back in year 2000, around 25 years back. So my SolidWorks instructor. So what he used to do, he used to every morning he used to get some plastic component from his home. So and he used to give it to us and ask the and give us some measuring devices like micrometers and tapes to measure it and then create it. So this is
That
how I have learned. And I believe this approach is going to add a lot of creativity to our budding, I can say, engineers.
Yes, definitely. And that was a good approach, because SolidWorks is a tool. And
Yeah,
the way
yeah,
I describe SolidWorks is a bridge between the
mm,
idea inside your head and
yeah,
what comes to this real world. So you could try to iterate all that and create an assembly of 400,000 components, except that you can't. That's why you need something like SolidWorks to bring it gradually, step by step, out of your mind, put it inside SolidWorks, and then eventually produce it and manufacture it and bring it into this world.
true, true, true. So let's get right into the action.
So I wanted to break this down into actionable steps. So by the time they finish watching this video, um, uh, by the way, this is only my humble personal opinion. I know I have students who are a lot more experienced than I am. They have maybe 40 years of working in the field, and I'm not even 40. So I'm not stepping on any toes. This is my personal opinion, and that's how I approach things. And I wanted just to break it down. So the first step is to find a problem. If you want to create a solution, you need to have a problem first. This problem could be something you or somebody else want or need. Doesn't matter if you're paid to do it, if you want to do it, if you like to do it, doesn't matter. It needs to be a problem, and we are going to think about a solution for that problem. Now, I have defined an example problem for myself. This is a photo of my ceiling, and it looks like this, literally. The house is old, and inside the cavity, there are a lot of small wires jam packed inside, and I cannot push anything, any lamp,
Mm.
install any lamp in it. So it has to be something on the outside. And since I have already installed that Spider-Man portal thing on my wall, I thought maybe I stick with the theme and do everything in a portal way. So I was thinking, okay, I if I want to put a ring light on my ceiling,
Mm.
how do I start? What I know is, let me just go to markup. By the way, just to clarify, you are seeing my desktop right now, and I thought it would be good to pay attention to the way I work with SOLIDWORKS while I'm having my left hand here. This is cherry on top, side bonus. To press escape at all times because it exits all the menus. This is how I work with SOLIDWORKS. It's like playing the piano. You need both hands. Do not work like this unless it's 12 p.m., 12 at night, and you're really tired. But that's how I work with it. So what I have here, the problem that I see is, okay, I have one, two screw holes here, and I have this opening that I need to cover. So this gives me my first input. I know, okay, good. So I have a diameter here to measure, and I have a distance center to center from these two, and it gives me something like this. And that's my starting point. And that would be good. So I'm going to take it from here. I have already done that. These are the actual values. And okay, what I want is a ring that looks like the ring that I showed you that is sitting on my wall. I just do quick. Good. I extrude this for 40 millimeters, and I end up here. Then this would be sitting on my ceiling, right? The wires are going to be accommodated inside this thing, but this is not the light itself. The strip light that I want to use inside that ring has no place to be here. I need to add the next step. And the next step would be thinking where the next part should be, how big should it be. These are all imagination. So we are at step 2 right now. We have defined the problem, and now we are um, at the idea step, imagining, okay, how do I want this lamp to look like? You need to have some approximate expectation of what the final product should look like. We are not talking about rendering the fine details. We are talking rough. Okay, roughly it would be something that sits there, covers that opening. I can screw them to the ceiling, and okay, there will be a ring underneath it, and it just shines the light to the ceiling. And okay, good. So roughly, I would say if it's about, I don't know, 150 millimeters below it, and if I have a ring that is about this big, just by looking at it, it would be good. So let's just go 400. This 400, I'm not doing anything final, just to be clear. And let's just do 20 and go mid plane. Okay, I'm gonna click OK. Good. So it would be something like this. If I connect this part to the ceiling, this would be my light. Now we are at the next step. We are seeing some challenges here, and we want to um, use SolidWorks in our advantage to overcome these challenges. We are iterating, okay? Roughly, we have the figure here, but we have to answer some questions. For example, how do I connect this ring to this component? Because it cannot levitate on its own, obviously, so there should be some connection over here.
Yeah.
And this is a question I have to answer for myself. It depends on my taste, because this component is functional in some sort of way, but it's not that critical. It's not a laser component being used in a rocket. So I
Yeah.
would be free or more flexible to decide how it should end up looking. I want to go to the next, jump to the next step, basically. Sorry. And say it would be like this. Okay. I could go ahead and do these steps slowly, but I think it would be smoother if I just show you. So this is the first bit. This is the next bit. I have the two screw holes. Good. They are here. And then I have the place for the lamp. I have to shell it.
Shall it?
Why? Because I have a strip light.
Hmm.
And at this point, I have to answer another question too, because things are about to become serious. Every step we take, we are actually um, fixing things more and more towards the final product.
Yeah.
So first, before I choose, oh, I want to shell it with a thickness of 3 or thickness of 2 or thickness of 10, doesn't matter. I have to know why. Where does this 3 coming from? So one factor I have to take into account is, first of all, how am I going to manufacture this? what's my manufacturing process? Is it going to be 3D printed, or am I going to use sheet metal to make this, or is it a CNC component, or is it made from wood? So this is a question I or everybody else has to answer for themselves. In
Yeah.
this case, I want to 3D print this. Good, that's fine. Now, one factor that comes to mind after knowing that we are going to 3D print this is how strong is our material? Like if I shell this with a thickness of 1 millimeter, which is really low, by the way. I'm just doing this for those who are used to work with the imperial system. I don't know how accurate you can see this, but this is 1 millimeter, and this
Uh,
is very thin. If I
yeah.
3D print,
Aryan, can you move it to the top camera, because it seems the overhead is not. Yeah. Yeah.
yeah, so this is 1 millimeter, right? And this is super tiny. If you look at it, if I 3D print a component that is so thin, obviously it's going to break very soon. So what if we do three? Yeah, something like this. It's a lot more robust and stronger, so I'm going to go with that. But that's not all. The other factor is I have to choose what kind of strip light I'm using here. So after choosing the one you want to use, maybe you have it, maybe you want to buy it, you have to find out the dimensions. So this one is 10 millimeters wide and 6 millimeters um, in height. Let's just call it the height. So I need to take that into account. When I
Hmm.
shell this, do I have enough room here? Do I
To
have enough
place it. Yeah.
space to place this strip light here? So yes, I do, and the height is okay, and the thickness for the 3D printer is okay. So more or less we are on the right track. Maybe it doesn't work, we don't know, but we need to take this into account.
Yeah, I totally agree with you, because whenever we start building something in CAD, we also need to make sure that it should design for manufacturing. Yeah.
Yes.
Yeah, otherwise we will spend a lot of precious time in doing something which is not actually manufacturable, or probably will increase our input cost. Yeah.
That's a great point, and this is something everyone should know for themselves. Either you are working with SOLIDWORKS or CAD for practicing your skills, and that's fine, or you are actually making something to be manufactured. In that case, you need to know DFM, design for manufacture, as you said.
Yeah.
Um, that's very important. You cannot just, you can, but you shouldn't just design whatever you think is good. It's not based on the looks, it's based on the manufacturing cost,
Yeah.
manufacturability of that component. Um, and there are more factors to it. If you are creating a system made of multiple components that need to be assembled together, you need to take into account, are they able to assemble this easily and dismantle it again, or it just works inside SolidWorks because it's virtual? So there is a difference. In this case, we are going to manufacture this. This is being designed for manufacturing. So we are taking the actual physical products that we want to insert or connect to this component into account.
Yeah.
Now I have that, and I have the top part, and it's shelled. Good. Now this part needs to be connected here. At first, I was thinking it would look good if I use some tiny wires to connect them like this in the back in here. And yeah, that kind of it's a different design, but it adds some complexity, which I didn't want to do. I was a little bit lazy. If you want to go this way, you have to take into account the connection point
Yeah.
here and the material, and make sure, because you are doing it with hand and this is not a batch production, how do you actually make sure each line is equal, it has is equal in length, and you are putting the lamp on the ceiling in a balanced way. So in that case, I thought this is not the approach I want to take. I'm gonna go and connect part one to part two like this. So this is the connection. It might not look good, but
Hmm.
hey, it works. This is this is for the sake of the argument. And next step is I need to insert this strip light from here. I don't know which camera you're
Um,
focusing on, but this one, I
yeah,
need to be able to.
Aryan, only your front camera is focusing at the moment because the
Okay,
overhead is somehow not, you can say, capturing. Yeah,
okay. So I can just point it out on SolidWorks. Doesn't matter.
yeah,
So the strip light has to go through this bridge and go around this and end
yeah.
here. So another factor that comes into play is the circumference and the length of this red line that I just drew, because the strip light cannot be shorter, or
Mm.
ideally it should not be very much longer either, because then I have to cut this and it's a waste of cost. So we need to find the right length of strip light before we actually start printing this, but we are still a couple of steps away from doing that. I need to open up um, a gap here so the strip light can actually sit inside this bridge as well. And it would look like this. I can do this right now because I have already designed this before. But the first time I modeled this, I did it like this. And I want to actually or purposefully recreate the issue to make a point.
Okay.
On default, we have the merge result
Merge
checked on
results.
SolidWorks. And when we are working in a multi-body design mode like this, the merge result is checked, so the components actually become one. Now I have only one solid body. And when I have this, or when I had this the first time, and I wanted to shell this, I knew it wouldn't go because
Yeah, yeah,
we have all the other components already shelled out. So what do? I have to go back, edit this. So these small iterations come to mind gradually. I cannot think about them in advance. As I'm
yeah.
working in SolidWorks, they reveal themselves, and these are the challenges that pop up, and we fix. So I uncheck merge result, I do the shelling, then I can combine them together.
Yeah, and I think it's a great approach to start any product like this, or especially a consumer product, with a multi-body approach, and then moving on to basically connecting it, bridging it with the rest of the bodies. And it's always a great approach to start with the multi-body parts. Yeah,
Perfect point. Yeah, thank you for bringing that up. Actually, this is the way I always do it. It's a lot faster because we are doing quick and dirty. We are not doing any final product. We
yeah,
just want to
yeah,
make sure we are on the right track. The dimensions are good. The material is not breaking. And then when it's time, we can go to the assembly mode and actually do the
yeah.
fine tunings at the end. But I always start in the multi-body mode and work right there and then, because everything is there, everything fits. It's not like, oh, bring a component, go back, edit it. Everything is under one roof.
Yeah, yeah,
So let me just recap to this point before I take it from here. So I said the first step was defining a problem. What is the problem? We want to create a ceiling lamp over there. Good, that's the problem. Second step was the idea or imagination. How do I want this to look like? Or how should it look like? Maybe you are tasked to do it in a certain way. Doesn't matter. But the idea should be there. Okay, it should be something that connects there. Then there should be a ring light roughly, and it connects there. And I could use a strip light, for example. Next step would be to start getting some real. So that was step two. Step three, we need to get some actual real life input. What was the input? Okay, I had two screw holes and one opening that needed to be closed, so I can measure those and bring them as inputs. I start from that point and eventually build on top of them. Sorry, where was I? I think here.
yeah,
Yeah, so we bring the inputs from real life and we go to SOLIDWORKS on a step four, start drafting. This is what I'm doing right now at step four. Okay, this bit goes to the ceiling. This bit hosts the LED strip light. This bit connects these two together. So physically we are able to hold them midair, right?
Yeah. Yeah.
And now some fine tunings come to mind. Okay, I need to open this bit and also open here so the strip light can actually go through them. So let me just go all the way, and I end up
Yeah.
something here. Why? Oh, except this one. Okay, now the strip light can go through, but it looks a little bit brittle. We are working with sharp angles, so
Yeah.
let's just do some fillets. It just reminded me of a presentation slide I saw at 3D Experience last year in Dallas. There was
Yeah.
a meme that engineers were modeling something, and somebody said, "Can you make that product look a little bit better?" He said,
Uh,
"Sure. Let me just add some fillets." So, yeah, it does make it look better,
yeah.
or
It always does. Yeah.
it kind of does. Yeah, it's satisfactory,
Yeah.
but it also adds some strength to it. So
Hmm.
we are not working with sharp angle 90 degrees,
Hmm.
so they cannot break.
Yeah.
So I'm like, okay, this is a good um, foundation for me. I go to the next step. The next step would be for me. Sorry, I just jump between the models all the time. The next step for me is usually rotating the component. It's kind of a habit for me. When I'm done, I keep rotating the component and I look at it from different angles without thinking about anything specific. Because every time I've done that, something comes to mind. Oh, why is it like this? Why should I do this? Oh, how do I fix that? Oh,
Hmm.
there should be a problem there. It's always good not to take action right away and take your time, go back, look at it again, maybe even stop working with SOLIDWORKS, take a break, come back again later. I assure you, there is always something that you have missed or you should still do. That's a guarantee. And after doing all that, I still miss something here.
Yeah.
So
Yeah. It's a great way to self review your work, and yeah, it gives you a lot of chances of improvement, and yeah, in your design process.
definitely, you need to catch your own errors.
Yeah.
Um, I've reached this step, and I'm asking myself, okay, I am going to 3D print this from PLA, and I don't know. Is it going to be stable? Is it going to break? Is it going to bend? That's a that's a question that I was asking from myself, and I was like, why don't I test this? Fortunately, I have the basic license for the simulations. Okay, doesn't matter. I can run it again. So what do I do? I this I define the fixed surface on the top where it connects to the ceiling, and I just add the gravity, and I just measure the displacement on the red spot, which is about 5 millimeters. It wouldn't look good if it bends because of its own weight. And on top of that, I'm going to add the LED strip light to it as well. So I want something that is sitting flat,
Hmm.
doesn't move. So this one looks good, but it's not doing the job properly. So we need to do some optimization. The first thing that came to my mind was, okay, how about sorry, I cannot click on anything. 1 second.
Yeah, maybe is there a window opened, or
Yeah,
maybe
probably I have to check. What is this? I'm gonna reopen this.
yeah.
Okay, so we had a displacement of 5 millimeters. Now, the first thing that comes to my mind, this can be chamfered.
Hmm.
Let's just do it this way, really quick. And I go back in and I run it again,
Well,
and I get this. Okay, what do I have after the chamfer? 3.5.
3.5.
So I just reduced one and a half millimeters of displacement, like 33%. So that's an improvement, but maybe it's not enough. I keep doing things like this nature. Maybe I chamfer this as long as it allows me to do it, as long as I'm okay with the look. Maybe it doesn't look good, then I have to find another solution, maybe make it thicker, the wall thickness,
Mm.
instead of 3 I can make it 4. And after playing or iterating with this,
Yeah.
I ended up here. It looked like this.
Amazing. So, Aryan, I remember we casually do the simulation and then do the modification. So now, if I just think from a designer's perspective, so we have this you can say advantage of CAD embedded simulation available inside SolidWorks, which basically help me to do the setup of my simulation problem, run the analysis, and then simply go ahead, make the design change, and then just rerun the analysis again. So now imagine if your if this integrated simulation is not existing, then eventually it's pretty hard to use a separate software for doing analysis, coming back, doing import and export, doing this analysis setup once again, and actually it eats up a lot of time. And this is where our integrated simulation basically gives us advantage of doing all these iterations in a very quick way.
It does, definitely, 100%. It's seamless. That's what it
It's
is.
seamless. Yeah. Yeah.
Yeah, that's the simplicity is very important.
True.
You might have a very good speaker at home, very good camera, very good radio, very good calculator, but your phone does all of that, and usually you don't want to jump unless you have to, unless
Yeah.
there is a very
Yeah.
special
Yeah.
case, because when everything is under one roof, it's easier.
True.
And I just wanted to show the end result, which is 6.4 to the power of minus 1. So it's like zero point 0.6 millimeters
Zero
of
point 0.6. Yeah.
displacement. Yeah, so it's almost negligible, and that's good enough for me. And one thing, another challenge that I did face, which I cannot show here, or maybe I could, is when I decided to actually sit down and print this. When I wanted to do that, I saved this component as STL and opened it up in my slicer program, and I realized the volume that my the volume that my 3D printer could offer was not big enough to accommodate this design in it. So
Okay.
at that point, I'm facing a new challenge.
Hmm.
Let me just try to add this. Maybe you want to share that. No, I already have. So I cannot share that. But it made me come back here and reduce the diameter, because at that point I had a couple of choices. I could segment this and then lock them together to keep the diameter the way it was,
Impact. Yeah.
or I could make it smaller. So again, this was a self-defined project. I had all the flexibility in the world. You don't have that all the time. Maybe your employer has given you a task, maybe your client has given you a task, you need to stick to some criteria. But I didn't have that limitation over my head, so I made it smaller. And I have to say, the other wall lamp that I showed you in the beginning, that's 1.5 meter in diameter, and that's consisted of over 32 components that I have connected together.
Wow.
Otherwise, I could have not, yeah, printed that at one go. So after I did this and I was happy with the results, I printed it. This is it.
Amazing. Yeah.
This is how it looks like. The strip light can go inside it. I'm gonna cut the wires and connect them directly to the ceiling myself. The wire sits inside. Everything was good until. Are you seeing my top camera too?
No, Aryan, we can't see your top camera. Uh,
Oh, we. So is
yeah.
it
Yeah.
disconnected?
Can you hold it up to your main camera, the front camera?
Okay, sure.
Yeah.
So
Yeah.
it sits inside it. Everything was good, and when I tried to connect it to the ceiling, I noticed an issue for the first time. If you pay attention to the holes that I have here,
Yeah.
they look fine, and I already took the space into account to put
Hmm.
the screws here, and it's fine. But the second one here is hiding behind the bridge,
Uh,
so I could
yeah.
not screw the
Hmm.
screw it to the ceiling from here, and that made this design obsolete. If I had spent more time looking at my design, I would have noticed that this hole that you're seeing on my screen is actually hidden behind the bridge. So I had to go back and end up on this.
Yeah, I would we can say categorize it as a issue of more from the design for assembly perspective. So where I was not able to
Absolutely.
assemble it because of the design issue. Yeah.
Absolutely. Absolutely. This is something that I knew
Hmm.
and I did not follow myself. So it
Yeah.
happened. All right. After this, the next step is actually to, this is the new design. Again, you're looking at it here. The
Yeah.
holes are
Amazing. Yeah.
displaced. We have the capacity to connect it to the ceiling. The opening is here. The bridge is here, and it's actually really robust. I can move it
It's
if
pretty
I
robust.
apply
Yeah.
force to it, but on its own, it's going to be stable. And this is one example of designing something from scratch. I know the example wasn't um, very attractive in the eyes of mechanical engineers. It's simple, it's one component, but I just wanted to bring the spotlight to the thinking, the actionable steps behind it, the way I have always done it, the way I see it.
Yeah, just to recapitulate, so what I have learned personally is, first is we should always think from the manufacturability point of view, from design for assembly. And any product like this where you are creating a concept should multi-body approach is a great way to start with. Yeah.
Absolutely. So I could just create some bullet points over here. So first, we start with multibody, as you mentioned. That's actually very true. I appreciate bringing it up. And you don't go for the details. You think
Hmm.
on the top level, the surface, okay, it needs to connect to this component. The other end should connect to that component. So you
Hmm.
start to take it like this. And then you eventually figure out all the details. After this one works,
Yeah.
if we are
Aaron,
honest, this is the
we have a question from an audience. So someone wants to know, how did you make that turn on the connected part? So probably if you can,
how did I make that turn?
yeah. So this connected part. So probably you have
Yes.
used sweep. So if you can just
Yeah.
go back in the modeling
Why,
and
why don't I actually go back and do this? How's that?
okay.
So let's just go here. It's
Yeah,
a
yeah,
sweep.
yeah.
But let's
It's
just
really
say
fine.
let's say I'm at this point for the first time. Okay. Now I know where the bridge should be. It should not cover one
Hmm.
of these two. So I'm gonna pick the right plane. If you have any questions, feel free to ask me. But I actually, since
Sure.
I'm doing it again from scratch myself, I try to put the focus on the model liquid, so that I'm not talking much.
Yeah, Aaron, parallelly, there is one more question. Someone from the audience is asking if uh, you have any videos or tutorials available on the multi-body modeling.
Um, I do, I do.
Okay.
I have multibody covered fully in detail inside my course, but if they are asking about a multi-body video on YouTube, I have that too. I don't know exactly where, I have to look at it, but inside my channel, definitely. Inside my course, most definitely. Yes, it's very essential.
Wonderful. Yeah. And
So,
I personally really like your shots as well. So, uh, a really good tips and tricks are you can say shown in all your shots. Yeah.
I appreciate it. So the
Yes.
way I saw it was that when the shorts were introduced to YouTube, I saw nobody's doing that for SolidWorks. I thought it's only fair to give SolidWorks a fighting chance. So I did a couple of them, and then I liked it, did more. I just did that to get the dimensions again reminded back to myself.
Yeah.
So
Yeah.
the flat surface, 15 height, 20.
Arun, there is one more question from audience. Does making use of splines make manufacturing more difficult? Uh, yeah,
Yeah,
I would say
absolutely.
it all depends. Yeah, right.
Absolutely, but we need to remember I am going to 3D print this. So for a
Yeah,
3D printer, it doesn't
agree.
matter. If you're actually going to CNC this or a different manufacturing method,
Hmm.
yes, they matter a lot.
Exactly. So this is what I also felt. Since you are using 3D printing, it's probably fine. But if it is needs to be injection molded, then probably we can think of using lines and arcs instead of spline. So I hope,
Absolutely,
yeah,
absolutely.
we are able to answer your question. And I believe if we think of mass producing it, then probably adding drafts would also add a lot of value over here. Yeah, because in 3D printing you can avoid adding any drafts because you are not going to get it out of the mold.
Oh, definitely, definitely.
Yeah.
And the other wall lamp, the big one, one and a
Mm.
half meter diameter, made
Yeah.
from 30 components. I had to use draft. Maybe I can bring that up on SolidWorks. So they lock into each other from one
Oh.
way and they
Oh, yeah.
cannot move. Yeah,
Yeah.
definitely. So see, it's actually is taking me. This is real time. This is Arion modeling for real. So I have to go back, fix this. Now I think it's good.
Hmm.
It's going a
Yeah.
little bit on
It's
the
good.
inside. If I'm
It's
a
okay. We can trim it later on. Yeah. Yeah.
yeah, exactly. So since I've done this before, I uncheck this beforehand.
Hmm.
Then I shell this for 3. Then I combine them together. Then I have to create an opening here.
Yeah. Yeah, there is a comment from Brad. Splines make the G code much more complex. If there are CNC codes of arcs, you can program the center and have the code sweep the arc.
Absolutely.
That's
And
one. Yeah.
I can go back right now. In fact, why not? If
Hmm.
we have time, I would go back and just replace this spline with arc. So this is one
Yeah.
opening. I'm sure they know how to do the other opening too. This is pretty quick.
Yeah. Yeah, I agree with you, Matthew. Splines look really, really cool, and if you are thrive for aesthetics, then spline is the better you can
Yeah.
say option. Yeah, yeah,
So this is how I do it. But since more than one person brought that up, I'm
yeah,
gonna try to. Oh, actually, you know what? Let's just have it here first.
yeah. Maybe you can just
Yeah,
make it construction. Yeah, yeah,
uh, do a little bit of cheating here, and then I'm gonna arc this
yeah,
like this. Then the G code wouldn't be a problem. The issue is somewhere else.
hmm.
The surfaces. I used to have one. I have 3.
Yeah. Because surfaces are regenerated, so the surface IDs are changed. Yeah,
Same with these 2 points. Oh, with the new SOLIDWORKS 2025, let me just try to fix this repo. Repo. Yeah, I like this feature.
Amazing. Yeah.
Yeah, so good. Now done. Now this is not a spline anymore. It's just a straight line, arc, straight line, and depends on how you want it to look like, and that's how I would do the bridge. And then again, do the do the engineer way of making it look cool. You add the fillet.
Filler it. Yeah.
Yeah. So yeah, that's how I would do it. Here too.
So I really loved Aryan that you are on the top of what's new. So you know what is latest happening in every release. Yeah.
Yeah, yeah. This one particularly caught my attention because this is really good.
Hmm.
These mustard yellow errors have
Yeah.
always been,
Yeah.
at some point when you're, especially, oh, this is maybe also a good point to mention, when you are modeling something like this from scratch for the first time and you are still within the multi-body mode and you are just adding and adding, this is a very simple component. But let's just say I did another design here. This is an assembly. I'm gonna bring it up. I did this one from scratch myself too, and it took a lot
Yeah.
longer. But if you pay attention to the design tree, you're gonna see a lot of errors. And at some point, because I'm just adding, it becomes like a challenge to go back and
Hmm.
fix those. So I did this before I had the 2025 to go back and fix it. But now that I have, I need to revisit this file again.
Yeah. Yeah.
Same approach. That was a one component designed from scratch. This is an assembly designed from scratch. Same concept. Everything is the same.
Yeah. So Raya commented, "Great SolidWorks skills, Aryan. Super inspiring to watch your work." Yeah.
Thank you. I appreciate it. I'm just always happy to share whatever I find with other people. And the reason I decided to talk about this topic, which was not that SolidWorks heavy, it was not covering
Hmm.
a lot of grounds inside SolidWorks, was the fact that I thought maybe this deserves a little bit of
Yeah.
spotlight.
Yeah,
Yeah,
I also believe, Aryan, because this topic will lay the foundation stone for engineers to think critically when they think of starting a new design. So I know it. We are not we are touching a lot of features in SolidWorks, but yes, this probably is going to be a foundation stone for yeah.
absolutely, absolutely. So when you are working with SolidWorks, you shouldn't be. I don't want you to be always looking for tutorials or
Mm.
drawings because the life is not that way. You're not
Yeah,
always a
yeah.
draftsman. Somebody gives you a drawing with all the dimensions defined, with all the materials defined.
Mm.
They just give you a problem. Hey, design something for it. I don't know how it looks like. You're the SolidWorks guy. But being a SolidWorks guy has nothing to do with the other. You need to have both, and
Yeah,
having both skills together creates a killer combo for you that makes you the man. And then you can just use SolidWorks in your advantage to bring your ideas and iterate on them and reach to the final product.
agree. Totally agree with you. And Eric Eric says thanks for answering questions live. Very useful. Yeah.
Oh, my pleasure. My pleasure. Um, I have a few minutes. Maybe we could go to the FEA, or if you have any other questions, I can cover them too. Is there any other pending questions from the chat?
Um, Sean, are there any pending questions? Yeah, I think we are all good for now. Yeah.
Okay, so if there is nothing else open, like no other question, I would like to run another FEA on this and
Okay.
I'll maneuver a little bit more on iterating according to some feedback, not just by the looks of it. So again, we are looking at zero point 0.5. This is a very stable design, so let's just not pick it from here. Let's just use a different one. Go back to here and use FEA in our advantage to reduce the bending. So we have a 4.9 and we
Yeah.
want to reduce it as much as we can. So
Yeah.
chamfer is a good way to go. to start. I just add that, and um, how about I increase the wall thickness to 3.2
Hmm.
and add some tiny chamfers here too.
Yeah.
Maybe I make them bigger and then run it again.
Yeah. And the best part is you have modified the geometry, but you need not to modify or redo your nodes and boundary conditions.
Yes, yes, it's really quick. So I just cut it by half. Instead
Hmm.
of 4.9, almost, I'm
Yeah.
looking at 2.6.
2.6. Yeah.
Yeah,
Yeah. Pretty
so
impressive. Yeah.
and it took me a couple of seconds. So if I wanted to do it more, maybe I need to do something about this edge, add some
Hmm.
fillet, and this might be a challenge for me because it's a continuous path and I need to break it down to add
Yeah.
some
Yeah.
chamfer there. Or maybe I go do something else. I would like to hear ideas if you have any.
So, any ideas or suggestions from the
Yeah, let's
audience?
hear
Yeah.
ideas from audience.
Yeah.
That would be
So in the
good.
meanwhile, Aryan, there is a question, or
Sure.
a comment, I would say. So Aryan, is the cat Chad aiming to get this to his level? So thank you for your content.
My pleasure. Oh, I know him. I know him. Xander is in my one of my forums. I know
Oh,
him.
okay,
Yeah, yeah.
wonderful. Yeah,
Increase the wall thickness.
yeah,
Okay, let's just do that because increasing the wall thickness might be a double-edged sword. It might increase the weight of the component, and
yeah,
so
yeah.
along with it, the bending. But let's just do that for the sake of the argument. Go to 5 and see what
Mm.
comes out of it. Now I have an error here, but let's fix that too. And try to run the study one more time.
Yeah.
So 2.2. No, it did help.
2.2. Yeah, yeah,
Yeah. So we can do this here. This is a good practice, and I appreciate the comment. But you
mm.
need to understand that if this component was to be manufactured and
Mm.
was to be maybe paid by you or the company you work for and be sold outside, you just increase your manufacturing costs because you are using more raw material here. The
Mm.
idea is to create a component as economically as possible and as strong as possible at the same time. So we have more criteria to cover. We cannot
Yeah.
just, otherwise, I could just create this from stainless steel, and I'm sure it's not
Mm.
going to bend, but it's
Mm.
going to be a very heavy component. It
Yeah.
adds to the FMEA
Mm.
table, the risk, because during the installation, if it falls on your feet, it might even do serious damage. So there are different parameters you need to take into account before
Yeah.
designing a component. Right now, we just simplified it for the sake of the argument for making an example in just 1 hour. But if this component is going to be produced, get certified, manufactured on the shelf outside, you need to cover a lot more areas, such
Mm.
as risk management, material cost, manufacturing cost, deliverability of the
Yeah.
components, and so on and so on and so on. So yeah, making
Yeah.
the wall
I,
worked, but
yeah, I think it was really enlightening for all of us to basically go back to the basics and probably think from a manufacturability point of view, from assembly point of view, and then probably incorporating the FEA in our design. Yeah.
oh yeah, that's always a bonus. Yes, that's a plus.
Yeah, so Aryan, thank you for this deep dive on SolidWorks Live Design. So before we go, would you like to speak about your online course, SolidWorks Course Pro?
Oh, yeah, I appreciate that. For if you don't know that, I have took it upon myself to put everything I have covered ever and more inside a sequence that makes it easy for you to understand, because informations only make sense and we only learn them when there is a special sequence of feeding them. And I have done that and called it SolidWorks Course Pro. So the way SolidWorks Course Pro works is it introduces everything step by step the way I think works for you. And for the past 5 years, the feedback I have received from more than 2,000 students is that they are all amazed by it. And at first I wasn't sure if this is working, but over the years I realized no, it was not only a few people, a few 10 or 100 people, it's thousands of people, and they are saying the same thing, and this is working. So I combine that with a daily support on the forum, so all the questions are answered daily, to make it impossible for you to not understand SolidWorks and not have it as your second nature. Because the way you can confirm this, the way you and I and all the other people who have been working with SolidWorks, they are CSWP or above, is that you don't think about your steps. I think about the solution. I want a lamp. I don't think about, but how do I do it in SolidWorks? I think about, okay, this is the connection. So let's just do that in SolidWorks. Click, 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 click. And it should be a ring here. Click, 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 click. But if you have to think about in between steps what happens in SolidWorks, you are stuck. You are about SolidWorks should not be a bottleneck for you. I want SolidWorks
Yeah,
to be a
yeah.
fast lane bridge for you, and that's what SolidWorks Course Pro does.
Thank you so much, Ian. And I believe SolidWorks Course Pro is going to be a great asset for the budding engineers. So with
Yes,
this, yeah. So
I
with
just
this,
want to say right now, I also this happened to be in the midst of it. I'm running um, an offer, so if they go there and check it right now, they can also take advantage of the offer too.
amazing, amazing. Thank you so much, Aryan.
My pleasure. It was my pleasure. Thank
So
you very much for the time and all the effort that you put into making this happen.
you are truly inspiring, brother. Yeah.
It's a pleasure. Thank you very much. It's my honor.
So subscribe and like this episode if you learn anything. So it's most functional way to say thank you here on YouTube. So we'll be back next month. See you then.